Okay, this is Exploring Blazor. We're going to talk about building interactive web apps using C#. I like to take a bottom-up approach and get one level beneath the technology. So we're going to do some background. First, I'm going to share just a little bit about myself. There's my actual picture. It was a great likeness there of Likness, if you will. This is how you can get in touch with me. I've got my email as well as my Twitter. I've opened direct messages for that. Follow me on my blog. I'm a cloud advocate for Microsoft. I've been developing professionally for a quarter century now, quite a bit. And just some random facts I like to run in quotes because I'm not fooling anyone. It's not very fast. I try to follow a 100% plant-based diet, although it's not always guaranteed what comes out of the kitchen is 100%, and I like to shoot pool whenever possible. It was actually fun at a local meetup. I mentioned I shoot pool, and someone stayed afterwards and wanted to know if we could get together and told me about a great pool hall in the Seattle area. So that was a lot of fun. But let's dive into the topic of discussion. If you are a .NET or a C# developer, these experiences, you probably know, are available for you. We can target the laptop, the server, the phone, the cloud. We can target games. We can even target sensors and IoT devices. But when we're told to build for the web, the answer is almost always the way that you build a rich client-side experience is by using JavaScript. What we're going to do today is sort of challenge that idea because there is a new technology called WebAssembly. And WebAssembly enables experiences across a variety of languages. Probably the most interesting aspect of WebAssembly is that it supports .NET. And I'm going to talk a little bit more about that, but I want to back up and focus on WebAssembly. So what is WebAssembly? The important thing to know about WebAssembly, there's a few facts. One is that it is a release product. It's not a beta product. Two is that it is available in all the modern browsers on both desktop and phone. If you have a modern phone client, whether it's Safari, Chrome, etc., this will support WebAssembly out of the box. What is WebAssembly? Well, it's basically what we call a sandbox stack-based virtual machine. It's a runtime, but it's a protected runtime. It's interesting. WebAssembly itself can't access any part of the browser. It's a black box. It can export functions and you can call and get values back, but it can't manipulate the DOM. But as a targeted virtual machine, it runs consistently on a browser wherever that browser may be, whether it's a 32-bit machine, a 64-bit machine, whether it's Linux-based, Mac-based, Windows-based. So it truly is a ubiquitous environment. WebAssembly provides bytecode. This is actual code that streams into the session without having to be interpreted like a script. So when you load that code, it's a direct array of bytes. This provides a much smaller file size, and it has its own specific instruction set. So if you're familiar with assembly language, there's different opcodes and operations. So it's not constrained by the JavaScript language. It is basically provided as a set of specific instructions, and we'll dive into that a little bit more. Now, to level set on the assembly part of WebAssembly, of course, I've been developing for a while, so back in the day, we would just figure out programs by scratching down ones and zeros on a piece of paper, right? And then we'd punch cards and feed them into a machine. I'm saying that a little tongue-in-cheek, but the good news is, even though this is how data is represented internally in the computer, someone really wise came along and said, binary is difficult to read and understand. Let's make it a little bit easier. And of course, we'll just go with a base 16 numbering system, make it hexadecimal, and we should be fine, right? Everyone recognizes AD20D0. Of course, some people said that's probably not good enough. Not everyone knows that AD is an actual instruction to the CPU to load the accumulator, or that 20D0 reference a memory address. So let's provide an assembly language that does this in logical terms. And the next logical step for anyone looking at this code is, of course, to assemble something like this, which is a actual program on the Commodore 64 on the 6502 chipset. Now, if I were to actually demo this, It's a very flashing and strobe light effect. So to save you that, this is basically changing colors on borders. Now we think about WebAssembly, why would we take a step back to that low-level assembly language? Well, I want to show you a couple examples that will hopefully help this make sense. Right now I'm in WebAssembly Studio. You can go to webassembly.studio.com and work with projects in your browser. And I'm going to create an empty C project. And I want to show you some of the steps of how this works. Now we've got a few files. I'm looking at the main HTML file. This is just a simple bit of boilerplate code. There's a span with a container, and there's a reference to JavaScript. So let's look at the JavaScript code. Right now the JavaScript code is using a fetch, which is a new JavaScript directive to pull a file in. It's taking the response and it's calling this WebAssembly object and telling it to instantiate it. So that is how you instruct the browser to read in WebAssembly and interpret it and make it available in the sandbox. And I'm just flipping over to make sure there's no comments. And then it's basically calling something exported from that. And in this case, it's calling main. We're going to change that up just a little bit. So we've got this WASM export. This is exporting it to be available to JavaScript. I'm going to change this to add. And we're going to do an integer x and integer y. And we're going to return x plus y. So we'll save that. And then we're going to change our JavaScript to call the add function. And we're going to ask it to add 38 and 4. And then we're going to do a save and run. So let's do actually build and run. So if you see down in the lower right corner, and I apologize, my Zoom's not working, but trust me, it says 42 in the corner. So that was successful. What it did is it took this higher level C, which is fairly straightforward if you're a C# developer. This probably makes sense to look at. But it turned it into this WASM file. And this is the actual assembly code that's associated with it. Now there's a lot of instructions here just to do a simple little add. It's basically taking this parameter, popping it on the stack, another parameter, popping it, calling add, which pops the last two things off the stack, replaces it with the value, and pulling that out. And you can see there's some other functions. But what's nice about WebAssembly is there's already support in higher order compilers to generate a format that's a set of tooling called LLVM. LLVM is a tool chain for creating portable applications. And some teams have been able to extend LLVM to generate WebAssembly code directly. That's what we're actually using here. So besides the fact that it opens up accessibility to new languages, it also gives us some speed benefits. So this is an application that I've hosted. You'll get the link to the source code and everything else for this. But what it basically does is it loads a JavaScript app that's computing primes. I'm going to click this button, and this is computing primes with JavaScript, and it's running a timer to figure out how long it takes to get to the highest prime number. It's going from 0 to 80,000. So you can see it's still churning. It's still churning. Pretty soon my fan will start spinning. We'll have a lot of fun with this, and this is actually the longest I think it's taken. So about 19 seconds for it to compute that prime in the browser. I'm going to come over here and click this WASM button. This is the same code that's compiled to WebAssembly. So we have JavaScript calling out, asking WebAssembly to compute the prime. WebAssembly hands it back to JavaScript, and we show it in the console. And that was 13 seconds. So we shaved off about 5 seconds. And this was a very simple example. But the reason why it was able to run more efficiently is JavaScript, and it's changing. Modern JavaScript is starting to get new types. But in general, for the longest time, it's held numbers as floating point values. What we're doing with these primes is integer math. Integer math is much faster than floating point math in most cases. And the difference between the JavaScript version, which is actually dealing with it as a floating point, and the WebAssembly is that it can deal with it as actual integer math, and it can gain some optimizations and speed from that. So the significant thing is if we compiled C# directly to WebAssembly, we wouldn't get much benefit because C# is a managed language, so it depends on the .NET framework. Just 2 years ago, a team was able to compile a version of the .NET framework that runs on top of WebAssembly. So we have to step back and ask ourselves, why would we use .NET for browser apps? And there's a lot of reasons. Probably the most common I run into is people want to use the language they know to build full web experiences. But on top of that, there's a huge .NET ecosystem. There's existing packages that we can plug into. .NET Stack has been optimized for performance, so it's already tweaked to run well on WebAssembly. This gives you a full stack experience. We have very advanced tooling for working with C# and .NET projects, and the entire framework is stable and mature. It's almost as old as how long I've been professionally developing. So it's had a lot of time for optimizations. Again, .NET by itself and WebAssembly would not be that interesting. You would compile a module, you'd call it, you'd get some data back, and that would be the end of it. So on top of .NET running on WebAssembly, we've got Blazor, which provides this full stack development. Now the key, as I mentioned, WebAssembly is available on all these modern browsers, so there's no plugin required, including mobile. These examples will run on your mobile phone. The way that Blazor got its name is it uses the Razor templating engine, but it actually runs and executes code in the browser. So the browser plus Razor gives us Blazor. So what this looks like conceptually is we have WebAssembly. On top of WebAssembly, we have the .NET framework. And on top of the .NET framework, we have the Blazor library that's giving us this full stack experience. So let me just give you a quick introduction to a Blazor app. What I did here was I did a file, new project. This is a brand new project that has client and server components. And then I ran it so that you see this. So I've got this hello world, how is Blazor working for you? Take our brief survey. We've got a little counter. We can click through the counter, and we've got this fetch data. So I'm going to go to the server and actually show you what this looks like. But before I do that, I want to open up my debug tools, open up network, and call this fetch data again, and kind of walk you through this stack. So what's happened in this stack as it's making these network calls is it's actually come through, it's called the fetch data route, this instantiated page. We can see there's a blazor.webassembly.javascript file. This is a file that helps load the WebAssembly portion. We've got this mono.js and monowasm. So the monowasm itself is the actual .NET framework compiled to WebAssembly. After that point, I've got the DLL for the client project I created, and we're just loading .NET DLLs directly in the browser. So this is not something that's compiled to a special type of code. This is .NET Framework and Blazor allowing you to work with DLLs as is. The other thing I want to show you is I've got the cache disabled. So if we look at the size over here, we can see that there's a lot of little downloads of kilobytes. We've got a bigger one that's 827 kilobytes. But what's nice about Blazor is it is a set of static website assets. So after that initial load, subsequent loads are often cached, including the DLL calls. So inside an intranet, you may not want to do this for a customer-facing app where you don't have control over the download experience, but definitely for intranet and enterprise apps, perfectly adequate loading time for what it's doing. And the team is working on optimizations to make those package size smaller and more efficient. Let's look at the code that it took to get this application running. I want to show you, I'll start with a simple, we've got a client and a server and a shared. So if we look in the shared, this is just a .NET standard class library that has this weather forecast object that has a few properties on it, including a property that's a computed property. It's just when you do a get on Fahrenheit, it's converting from Celsius. The server is a controller that is providing us with some random weather. You can see here it's using that weather forecast object, and it's just creating some random values for that. Now let's go to the client project. The client project starts up like you would expect a MVC style project to start up. And you can even configure and set dependency injection here, do everything you're familiar with. But this is actually executing inside of your browser. So if we look at these pages, we've got a counter, for example. And if I open up the counter, the way this looks is I've got HTML markup in my Razor template. This is how I data bind. I'm saying @ and so you're going to look for a property with this value to show it. This is how I intercept an event. I'm intercepting the onClick event, and what I'm doing is calling increment count. And then we can see we've got this current count 0, current count ++. What's even more interesting is if we come over to this fetch data, because the fetch data is actually injecting an HTTP client. So it's using dependency injection. This HTTP client is the HTTP client you're used to working with in C#, but it's been optimized for running in the web because behind the scenes, obviously, it's using the fetch protocol. So there's a little bit of nuance around what's available in the sandbox. But if we look at the call, it's using the getJSON async, and that's all it's doing is just assigning the forecast, and then we have a template that's iterating through. So if you're used to dealing with Razor templates on the server, exact same syntax here, only this C# code is actually running in the browser. Now that's a very high level introduction to that. Blazor is so much more. It provides a component model, there's a debugging experience, there's routing, there's unit testing, working on assembly trimming so that basically if you reference a DLL, it's only pulling down the portions of code that you're actually using. You can see forms, validation, publishing layouts. There's a lot to it. I want to dive into a little more in-depth example just to show you some of the power. So what I'm going to do is actually move this off screen, but we'll move it back on. There's a little bit of an issue if I do a file new where I was. It's going to pop off screen and create issues. But what I'm doing is just file new. I'll actually show you the dialog when it pops open. So I'm creating a new project, and I've got the 2019 preview. You can do this if you have the stable Visual Studio 2019. You just have to make sure that you enable preview bits. That's a setting that you go into that you can search in the search bar, but enable preview. That's a checkbox, so it lets you install preview. And if you go to blazor.net, which is one of the links that I'll share with you, it'll give you instructions for installing that. We're just creating a web application. I'm going to go next, and then it's asking me for a name, and this is where I move it a little bit just to make sure my create dialog doesn't go crazy on me. Okay, so now what it's asking for, let's drag this back on screen, is the type of application. So we've got a Blazor server app, which unfortunately I don't have much time to talk to, but in a nutshell, Blazor separates the logic for building together components from the logic for rendering them. So it is possible to build a Blazor app that runs on the server and has a lightweight client that uses SignalR to ask the server to build up the HTML and then draws it on the screen. That is going to be in release with .NET Core 3. So when .NET Core 3 releases, that'll be a part of that. The client side is the one that actually runs in the browser. That's what we're focused on today. And the client side, there's some nuances around optimization, performance, speed, size, and the debugging experience that the team's working on to get it to a production level quality before that is released. So that'll happen a little bit after the .NET Preview 3 release. So we can do this ASP.NET Core hosted. I'm just going to do client side. With client side, this is a true static application that's output. In fact, the examples that I show for Blazor that I connect to in my links at the end of this, they're all just hosted on a static website, because that's all this is a static set of assets that happen to use WebAssembly. So I've got my default project. I want to do a couple interesting things. First, I want to show you how to make a component. So we've got this survey prompt. It's a HTML template, and my German Shepherd's a little excited about this. That's who you heard in the background. But I've got this HTML template, and then I've got this title that's passed in, and that's bound up here. just by declaring this as a Razor web view, this is reusable as a template. So what I can do is on my main page, right here, we've got this survey prompt. I can do as many of these as I want. So I can do survey prompt. It can tell which attributes are available. This is the second one. And it's just automatically reusable in a way that makes sense to me. So I'm going to save that. Let's do start without debugging and just show you that component that's duplicated on the screen. And if this is taking too long, I'm going to pull out the trick that I always use, which is to encourage the machine to run faster and move the mouse in a clockwise rotation. We're slowly working our way through. Now, what's interesting about what's happening here is it's taking all of the project assets, building out a bundle of DLLs, WebAssembly, JavaScript, etc., and then it's just spinning up a lightweight static website server so that it can serve it locally for me to check out. So I'm going to close this previous example. We'll let it load this newer example. And we'll give it just a second. Dun, dun, dun. And here we've got our two prompts that basically have a different title because we were passed to it. So that's interesting, but let's do something a little more involved and really show where the power of Razor shines. If you've been in C# development for any period of time, if you were maybe around during Silverlight and WPF, pretty much the guarantee is everyone wants to build their own MVVM framework, which I'm not going to do today, or they want to build their own blog engine. So let's get started with building our own blog engine just to see what we can do. I'm going to prompt enter your blog text. I'm going to give you a text area. We'll give it 5 rows and let's say 80 columns. And we're going to do a bind value equals blog. Let's call it that. And now I'm getting a little squiggly because I said I'm going to bind to something, but I haven't declared it. So I'm going to do string blog. And we should be good. I might actually have to do an @ to make the squiggly go away. Let's see what we're doing here. Just do bind equals. There we go. Bind equals blog. I'm going to give you a button. And on the click event, we're going to convert. Let's actually do a little break after this. So now it's upset because I don't have the convert, and that's okay. And then I'm going to do @p and result. So let's do a string result. And then let's create the convert method. And this is going to be a very boring method right now because I'm just going to take what's inside the result or what's inside the blog and send it to result. So let's go ahead and start that. So very simple, text area that's bound to a value, a button that you can click to convert it, and a result. We're going to spin this up and see how we did as far as using the template, using the built-in data binding attributes to make that happen. So we're loading. Okay, so I can enter my blog text, so I can do like a header. Notice I'm using Markdown. Of course, there's no reason why I would think this has Markdown support, and if I do convert, it's just bringing the text through, which is exactly what I expected. So let's do something a little more interesting. I'm going to go into dependencies and manage NuGet packages. And I'm going to look for a Markdown NuGet package. So I'm going to just type Markdown in the search bar. Here's a Markdown package. It's an open source C# implementation of a Markdown processor. Apparently it was featured on Stack Overflow. And you can see this is a .NET framework and .NET standard. So there's nothing Blazor-ish about this. This was not designed specifically for the web. It's just an open source library, but we're going to go ahead and install that and sign our life away. So we'll click the OK dialog there and accept all of the permutations of licensing and usage and everything else. Hopefully none of those said I'm not allowed to live demo this in a certified fresh event. We'll come into this index, and then what I can do in my Razor pages is I can do a using directive. Let's see if it finds Markdown. Actually, I'll come back to that. So what we're going to do here is we're going to say it's hey red Markdown sharp. So let's go ahead and do a using for that. Using hey red Markdown sharp. So we're going to do a new Markdown here. We're going to say result equals Markdown transform blog. So we'll save that. I'm getting some complaints, but I think maybe my semicolon's throwing everything off. All right, I'm just gonna, yeah, there we go. It settled out. So we'll start this without debugging. So again, pulling in just a DLL. I don't have access to the source for Markdown, so I'm not able to reverse engineer it. But I'm gonna pull that into the .NET that's running in the browser and hope that it works to parse Markdown in my client-side experience. And that's the other thing that when I was showing you the example app that used the weather forecast, the shared library defined one weather forecast, and that single class was shared between the client and the server. So you can imagine the power of that. If I use data annotations and validations, I can have the same server-side and client-side validations on both without having to rewrite code or rewrite my validation rule set in JavaScript. So let's do this. Let's do header, subheader, A, and then let's go ahead and do a link to my blog, because why not do a shameless plug to blog.jeremylikness.com. And I'm just going to save this in case I want to reuse it. We'll click convert. And the convert worked, but what happened was it's escaped the Markdown. So we're seeing HTML tags, but we're seeing essentially escaped Markdown. There is a way in Blazor to mark data as safe. What it's doing is it's protecting you from someone arbitrarily posting something malicious into the text area and actually executing it in the context of the website. But I happen to know a few tricks that I can use with Interop that'll make this work a little bit better. So the nice thing about Blazor is it's designed to interoperate with existing JavaScript. So if you have existing JavaScript libraries, you can call those libraries. You can also call into Blazor from JavaScript, which is pretty cool. So let's do a JavaScript file. I'm going to call it markdown.js. So I'm putting that in my www root here. And what I'm going to do is assign an object to the window called markdown. So this is how we define an object in JavaScript. I'm going to give it a method transform. And that method is going to take the source text and a target element. And then we need to tell it what to do. So I'm going to create a transformer, robots in disguise, Autobots wage the bout. Okay, I'm dating myself now. So we're going to create a text area. Now here's an interesting trick. I'm not actually rendering that text area. But if I set its inner HTML to that text that came in, then I can move the value of that text area into the inner HTML of my target element, and it'll unescape it. So again, I'm creating a temporary text. I'm using a JavaScript trick. This has nothing to do with Blazor. But I'm taking text and an element in the DOM. I'm creating a text area. That text is going to the inner HTML of the text area. That turns the value into the escaped HTML, and I'm moving that back to an element. So that may or may not make more sense when we actually pull it into the application. So let's go to the index and make sure our script is included. So we're going to do script source equals current library, markdown.js. So that ensures it's there. And then we're going to go back into this index. And we're going to do a few things here. First thing I'm going to do is inject a reference to the JavaScript runtime. I'm going to call it JS runtime. So I'm saying I want to interact with it. So dependency injection, hand me something that I can use to interface with that. Then we're going to make a few changes here. I'm going to actually change this P to be @ref equals result. So this is the way I reference an element through data binding. So what I can do down here is I can turn this into an element ref. And what that's doing now is it's giving me a handle to this tag in the DOM. And you can think about how useful that is. If you have components that are reused, I might have 20 instances of the component. Instead of trying to find it by an identifier, I can just use this reference and know that I'm grabbing the right one. Now this is giving me an error because of the transform. So what I'm going to do is bar text equals markdown transform. So it's the same steps as before. Now I'm going to use the JS runtime to make a call. Actually, we need to, I'll just fire it off. It's an async call, but instead of converting the method, let's just do JS runtime invoke async. Now we could await and actually return a value from JavaScript if we wanted to. I'm just doing fire and forget. The name of what we're calling, it was markdown.transform. So that was the object on the window and the method. The first parameter is the text, and the second is the element that it's going to pass the text to. So that's basically making a call out to that JavaScript that I just created, passing it the escape text and a pointer to this paragraph element. So let's go ahead and start this. While I'm doing that, let me pop over. What about DLLs living on the client side with Blazor? Can they be disassembled? Yes, they can. So it's just like if you're deploying a client app to a user and they have the DLLs on their machine, they'll have the same access as if they install a desktop app, having those pulled down in the browser. They will be able to see them and disassemble them. So obfuscation, I'm not even going to be able to pronounce that word today, is something to think about. And this is another reason why server-side Blazor may be compelling. You can use the Blazor library, keep your DLLs on the server side, or move them behind an API so they're not distributed to the client. All right, I'm going to paste the text that I had before. We're going to click convert. And there you have the HTML actually converted out. And if we click on this, which of course I had to, it's going to take us to my blog. So that worked out nicely. I just want to show you one more aspect of this, and then we'll open up to questions and wrap. I'm going to add under shared a new class. I'm going to call this class exports. It could be called anything. The name really doesn't matter. I'm going to make this a static class. I'm going to make a method called transform that takes in text. And then what I'm going to do is create a new markdown object. And I'm going to return markdown.transform text. Now what's different about this class, and the reason why I'm creating it, is I'm going to tag this with a special property called JS invocable. This instructs Blazor to make this class available to JavaScript. Now I don't have to worry about the fact that we're dealing with low-level WebAssembly and conversion of text and number and everything. Blazor built in will make all those translations for me. So we're going to start this without debugging. The only change we made was we've now exposed that library so that it's invocable from JavaScript. We'll let this run. And this time I'm going to pop into my web console. and I'm going to call alert. What I'm going to call alert on is .NET, that's exposed by Blazor, .invoke method, that is what allows me to call a method. Now what it's expecting is the name of the assembly, because remember we can have multiple assemblies, so that's web application 4. The name of the method, which I call transform, and then I need some text, so I'll do head, new line, subhead, new line A, new line B, and we'll hit enter, and there you see the HTML transformation of that text. So what I'm showing you right here in this application is an application that's taken a third-party DLL, never intended to be run client-side, is running client-side. We're using it to convert Markdown in the browser. You can see that the performance is pretty much instantaneous. We could probably run perf metrics and see how long it really takes, but for a usability perspective, it's responsive. And we have interoperability from .NET calling out to JavaScript and JavaScript calling back into .NET, which is a pretty powerful set of capabilities. Having said that, everything I showed you walking through Blazor is available at this GitHub repo. I also have a set of blog posts about Blazor. They cover things like I take an Angular application and I rewrite that application in Blazor so that you can compare and see what the two experiences look like. And I also talk about implementing the MVVM pattern. I've had people ask me this. Believe it or not, some of you may be in this situation. There are still Silverlight applications running in the wild, but regardless of if it's Silverlight or WPF, if you have an MVVM-based application, it is very possible to port the majority of that code into Blazor. You'll have to use the Razor templates to mark up the UI, but the rest of it is available. Having said that, this is what I came here to show you today. I wanted to give an introduction to the background of WebAssembly and walk you through Blazor. I'd like to open it up now for questions.